Today you will learn to use the principle of mathematical induction to prove a conjecture is true for products. The induction process for products. For the proposition Pn, firstly state the proposition. Then show one particular case is true. For example, show P1 is true. State the assumption for Pk. This means rewrite the proposition with k's instead of n's. State the left-hand side for the Pk plus 1 case. Use the assumption for Pk and algebraically manipulate the left-hand side to show Pk plus 1 is true. And finally, write the concluding statement. Consider this example. We will use the principle of mathematical induction to prove that the following proposition is true for all positive integers. N is an element of Z+. The first step is to state the proposition. In this case, our proposition is 1 plus 1 times 1 plus a half times 1 plus a third times all the way up to 1 plus 1 over n is equal to n plus 1 for all positive integers. We then consider P1. For this particular proposition, the left-hand side equates to 1 plus 1, which equals 2, and the right-hand side equates to 1 plus 1, which equals 2. Therefore, P1 is true. We now assume that Pk is true, so we replace the n's in our proposition with k's. Next, we consider Pk plus 1, focusing on the left-hand side first of all. We have 1 plus 1 times 1 plus a half times 1 plus a third up to 1 plus 1 over k. Adding in the k plus 1 element, we have 1 plus 1 over k plus 1 on the end. We now rewrite the left-hand side of our Pk plus 1 case by using the assumption. So we replace the first part of the expression with the right-hand side of our assumption, k plus 1. So we end up with k plus 1 times 1 plus 1 over k plus 1. If you focus on our second bracket, we have two terms, so we need to get a common denominator to try and simplify it. The common denominator being k plus 1, so multiplying 1 by k plus 1 over k plus 1. We can then cancel out the k plus 1 common factor top and bottom, which leaves us with just the numerator of k plus 1 plus 1. We now make our final statement. Since P1 is true and Pk plus 1 is true whenever Pk is true, Pn is true for all positive integers.